Let's look at summation depending on Gregory series. Okay, concept wise it's the same. So let's proceed with the first problem. Let's say we are given e to the power of alpha cos beta minus 1 by 3 e to the power of 3 alpha cos 3 beta plus 1 by 5 e to the power of 5 alpha cos 5 beta minus and on and on. So again, this would be your cosine series, that is C equal to. So the corresponding sine series would be e to the power of alpha sine beta minus 1 by 3 e to the power of 3 alpha sine 3 beta plus 1 by 5 e to the power of 5 alpha sine 5 beta minus and on and on. Okay, so C plus IS would be these two terms. E to the power of alpha is common, so E alpha, and cos beta plus I sin beta would be e to the power of I beta minus 1 by 3 e to the power of 3 alpha, and this would be e to the power of 3I beta plus 1 by 5 e to the power of 5 alpha, and this would be e to the power of 5I beta minus and on and on. Now let's combine these two. So e to the power of alpha plus I beta minus e to the power of 3 is common, so alpha plus I beta by 3 plus e to the power of 5 is common, so alpha plus I beta by 5 minus and on and on and on. If you remember Gregory series says tan inverse of x is equal to x minus x cube by 3 plus x to the power of 5 by 5 minus x to the power of 7 by 7 and so on. So here x is equal to what? E to the power of alpha plus I beta, right? So which means our C plus IS becomes tan inverse of e to the power of alpha plus I beta, which can be written as tan inverse of e to the power of alpha times e to the power of I beta. Okay? Now tan inverse of e to the power of alpha remains as it is. E to the power of I beta can be written as cos beta plus I sin beta. Okay, C plus IS. Now, can we do anything else here? Uh, no, we can't really do anything. But what are we interested in? We are interested in the cosine series, that is C. So we have to get rid of this IS, imaginary part. So what we'll do is, we will do C minus IS. So that when we add, what happens? IS disappears. So this would be tan inverse of e to the power of alpha cos beta minus I sin. So now let's add C plus IS plus C minus IS is equal to tan inverse of e to the power of alpha cos beta plus I sin beta plus tan inverse of e to the power of alpha times cos beta minus I sin beta. Here is gets cancelled and we are left with 2c is equal to tan inverse of e to the power of alpha cos beta plus I sin beta plus tan inverse of e to the power of alpha cos beta minus I sin beta. Tan inverse of A plus tan inverse of B is equal to tan inverse of e to the power of cos beta plus I sine plus, that is a plus b by 1 minus ab square. So e to the power of alpha cos beta minus I sine beta divided by 1 minus e to the power of 2 alpha, because we are squaring this. Then cos square beta minus I square sine square beta. We are doing a times b. So a times b is what? A plus b times a minus b. So a square minus b square. Okay, tan inverse of e to the power of alpha cos beta plus I sine beta plus e to the power of alpha cos beta minus I sine beta divided by 1 minus e to the power of 2 alpha. Now cos square beta minus I square, that if we remove this I square, this becomes plus. So cos square beta plus sine square beta is 1. So we are left with 1 minus e to the power of 2 alpha. Okay. Now tan inverse of, let's take care of the numerator. What do we get? We get e to the power of alpha cos beta plus e to the power of alpha I sine beta plus e to the power of alpha cos beta minus e to the power of alpha I sine beta divided by 1 minus e to the power of 2 alpha. So here sine gets cancelled. So we are left with tan inverse of 2 times e to the power of alpha cos beta by 1 minus e to the power of 2 alpha. Now this is where the tricky parts comes in. You have to remember that in the denominator, if we get e to the power of an angle minus e to the power of minus the same angle, we get some kind of a identity. We can proceed further. So how do we convert this 1 into e to the power of? So tan inverse of 2e alpha cos b beta by, now here what we are going to do is we are going to take out 1 e to the power of alpha. So if we take e to the power of alpha out, what do we end up with? We end up with e to the power of minus alpha minus e to the power of alpha. But we want it in the reverse order. We want e to the power of alpha minus e to the power of minus alpha. So we take minus out as well. So e to the power of alpha minus e to the power of minus alpha. This can be written as tan inverse of q cos beta by, this minus we can take it up, and e to the power of alpha minus e to the power of minus alpha is 2 hyperbolic sine alpha. Okay, and now 2 and 2 get cancelled out, minus we can take it out. So tan inverse of cos beta by hyperbolic sine of alpha. Here we have 2c equal to, if you remember, we have 2c equal to, so c would be equal to minus 1 by 2 tan inverse of cos beta by hyperbolic sine alpha. So that is the expression for summation of this series. Okay, now let's look at the second problem. Now the second problem is we are given a series 2 by 1 times 3 sine 2x minus 4 by 3 times 5 sine 4x plus 6 by 5 times 7 sine 6x minus and dot dot dot. Before we actually look at sine series or cos series, we need to manipulate this in such a way that we can uh, work on it. So let's do one thing. Let's say, so this we can write it as 1 plus 1 by 3, which gives us what? 3 ones 3 plus 4, 4 by 3. But here it is actually 2 by 3. So that 4 has to be reduced by half. So half, we take it out. Sine 2x. So basically what we are trying to do is the coefficients, we are splitting it into two fractions. Minus, now this can be written as 1 by 3 plus 1 by 5. What do we get if we do this? 5 3 is 15 in the denominator. In the numerator, we have 5 plus 3, 8, which is double of this. So we have to reduce it by half. So take half out. Sine 4x. Same way, we will end up with half of 1 by 5 plus 1 by 7. Sine 6x. And on and on and on. Verify it fast. 7 5 is 35. That is okay. 7 plus 5 is 12. Divided by 2 is 6. If you notice, all the terms have half in. So let's take it out and let's multiply this off. So sine 2x plus sine 2x by 3 minus sine 4x by 3 minus sine 4x by 5 plus sine 6x by 5 plus sine 6x by 7 and on and on and on. Okay, now which means uh, this is not a recognizable this one, so we need to because by 3 by 3 by 5 by 5 they are all coming twice. So let's split it into two series. So if we split it into two series, what do we get? We get sine 2x minus sine 4x by 3 plus sine 6x by 5 and on and on and on. Then the second series would be uh, what are we left with? Sine 2x is gone. Sine 2x by 3 is remaining. So sine 2x by 3 plus, no, not again plus. Let's, what is the next one? Minus sine 4x by 3 is already gone. So minus sine 4x by 5 plus sine 6x by 7 and on and on and on. Now here, uh, what we need is, and by the way, this half is applicable to both. So let's put a half here as well. Uh, this is okay. Now here we need uh, 1. Okay, so if this is positive, this should be negative. That means this should be positive. That means this should be negative. So that means all the signs are getting changed. So let's put a minus in the beginning. Now here we have added 1. So minus 1, right? Okay, now that we have done this, what have we achieved? We have got one series here and another series here and minus 1. So let's write it as half of S1. Let's call this series as S1 minus, let's call this series as S2, and we have, but this minus, this will be minus 1, this will become plus 1. That would be problematic, right? We will end up with minus 1 minus 1. So this should be plus 1 so that they cancel out. So that means plus 1. So now we have to handle two series. So let's take it separately. So S1 is will be equal to sine 2x minus sine 4x by 3 plus sine 6x by 5 and on and on and on. That means its corresponding cosine series would be cos 2x minus cos 4x by 3 plus cos 6x by 5 and on and on. Okay, so C1 plus IS1 would be cos 2x plus I sin 2x. So that would be e to the power of 2ix minus e to the power of 4ix by 3 plus e to the power of 6ix by 5 and on and on. Now here we want it to start, the series to start from e to the power of ix, not 2ix. So let's take one eix out. So this will be ix minus e to the power of 3ix by 3 plus e to the power of 5ix by 5 and on and on and on. Okay, so now this is your Gregory series. So we know what this is. This is going to be tan inverse of e to the power of ix. Okay, so that is the first series. Now the second series is what? Second series is 1 minus 2x by 3 plus sine 4x by 5 minus, so let's write it down. S2 is equal to 1 minus sine 2x by 3 plus sine 4x by 5 minus sine 6x by 7 and on and on and on. What do we do now? C2 cosine series would be minus cos 2x by 3 plus cos 4x by 5 minus cos 6x by 7 and on and on and on. So now C2 plus IS2 would be 1 as it is minus cos 2x plus I sin 2x would be e to the power of 2ix by 3 plus e to the power of 4ix by 5 minus e to the power of 6ix by 7 and on and on and on. Okay, now what do we do? Here let's again, we need the Gregory series needs the first term to be e to the power of an angle. So let's take e to the power of minus ix out. So to make it 1, we have to have e to the power of ix minus. Now what will happen? E to the power of 3ix, 3 minus 1, so it will become 2 by 3 plus e to the power of 5ix by 5 minus e to the power of 7ix by 7 and on and on and on. So again we have got the Gregory series. So this can be written as e to the power of minus ix times tan inverse of e to the power of ix. So we have got S1 and S2. S1 is the imaginary part of this, right? And S2 is the imaginary part of this. So so which means we need only this imaginary part. So how do we get that? Directly we can't do that. So what we'll do is we will directly say S1 minus S2 is equal to e to the power of ix tan inverse of e to the power of ix minus e to the power of minus ix tan inverse of e to the power of ix. Actually this should have been this and this. Remember, we don't want the entire thing, only the imaginary part of this expression. Okay, let's see whether we can do that. So here tan inverse of e to the power of ix is common. So tan inverse of e to the power of ix times e to the power of ix minus e to the power of minus ix. This one and this one. Now we know that e to the power of ix minus e to the power of minus ix is equal to, so e to the power of ix minus e to the power of minus ix is equal to 2 by 2i is equal to sine x, right? That means if we take it to the other side, this becomes 2i sine x. So 2i sine x. Okay, that is one thing. Second thing is, uh, let's say tan inverse of e to the power of ix is equal to p plus iq. So this expression becomes p plus iq times 2i sine x, and if we multiply it off, we get 2p I sine x plus 2q I square sine x. This I square, if we cancel, this becomes minus, right? So which means this becomes a real quantity. So 2p I sine x minus 2q sine x. But what are we interested in? Only in the imaginary part. So imaginary part is this 2p I sine x. So S1 minus S2 is equal to 2p sine x. So the imaginary part will be 2p sine x. Now p plus iq is equal to tan inverse of e to the power of ix, which is what we did here. Now p minus iq would be what? That would be tan inverse of e to the power of minus ix. This can be written as tan inverse of cos x minus, plus I sine x. This would be equal to tan inverse of cos x minus I sine x. Okay, so let's take this 2p sine x, right? No, before that, let's add it up. What do we get? IQ get cancelled. So 2p is equal to tan inverse of cos x plus I sine x plus tan inverse of cos x minus I sine x. Okay. Now tan inverse of A plus tan inverse of B will be tan inverse of A plus B, that is cos x plus I sine x plus cos x minus I sine x divided by 1 minus A times B. So A times B is this times this. So which means A plus B times A minus B. So A square minus B square. So let's do that. We get cos square x minus I square sine square x. And if we cancel this, this becomes plus. And cos square x plus sine square x is 1. 1 minus 1 is 0. So denominator we get 0, which means tan inverse of infinity. Now tan inverse of infinity means the angle is equal to pi by 2. So 2p is equal to pi by 2, which means p is equal to pi by 4. Now what do we do with this p? Remember, here we had 2p sin x. This should have been 2p sin x, right? So that p we have to substitute. Now that we have got p, let's incorporate it into this 2p sin x. So s1 minus s2 is equal to 2 pi by 4 sin x. So 2 cancels. Pi by 2 sin x. Not only that, we also have to add 1 to it. See here, s1 minus s2 plus 1. And we have to divide it by 2. So half of s1 minus s2 plus 1 would be equal to half of uh, s1 minus s2 is pi by 2 sin x plus 1, which gives us pi by 4 sin x plus half. So that is the expression for evaluating this series. Okay, I think that's enough. Bye.